pakai gitu atau
balik-balik aja memang gue beli gue pakai emang guna aja lu nggak pakai kan nama badan lu basah juga kalau gue jalan ya sebenarnya bawa ke sini
oke, at least lo ditawar dulu kayak maksudnya kan berarti kan kita ada backgroundnya tuh lo bisa hindari anjir
paling smart aku ada tiket di China. Aku tuh tiket aku bisa next time lagi. Next time. Rolling.
Kan di grafiknya tuh karena di grafiknya itu D per D sama ada yang per D.
Kira
kayak ini KT-nya D per D.
Jadi grafiknya begini.
Kan kalau lu lihat grafik ini yang bagian atasnya D per D.
maksudnya baca Nigerian National Robot Association.
Iya, itu kira benerannya. Bukan apa bukan collab kecil kan? Kecil. Harusnya keras. Gua kan.
Coba aja lempar ke Ian.
Ya coba sini. Ini ya guy yang udah tag. But it's like super far away guys. Jadi moments just for like one frame. For like what? Like it's not.
Morning. Orang buat pedok. Lu tahu pedok kan? Yang buat standar 2-nya motor.
Tahu.
Ini bannya.
Oh. Ini beli.
Masa curi dia.
Lu pakai ini?
Is the free pass showing up in Google Classroom?
Iya.
Go ahead and start doing it.
Ska, lu kemarin hilang kemana Ska? Seharian nggak ada. Oh.
There is the post, but there is no Google Forms.
Sir.
Oh enggak, kalau misalkan bonding
Tapi kok nggak belum bisa. Belum bisa kok.
ini saya belum pernah itu bonding
Kalau mau nanti kita beli fiction tape aja. Yang kayak dipakai buat nge-DJ yang kayak ampas. Yang tape kita pasang. Pakai bola. Ini. Oke, itu dipakai buat tanjakan.
Is the problem showing up now? No? The precast? No. Is it still empty? That's weird.
Okay. Biar lebih gede. Apa namanya? Siapa sih yang lebih kecil? Ya tapi ringan kan? Ada bisa dulu baju dulu. Itu jatuh pakai baju juga masih pakai. Di baju juga masih pakai. Oh bisa beli mak isi. Sekali nggak ada. Oh ini bisa? Batas orang pak, tapi kalau beli yang 10, apa per 10
Hasilnya 9.000.
Itu berapa? Apa? Ini 6.500. Ini 6.500 karena diskon. Aslinya 11. Roda skateboard lebih kecil. Oh bukan roda skateboard. PE berarti. Iya itu PE, PE free. Ada yang jual harga 2.000. Emang kalian kan sedikit aja sih robotnya. Kalau yang
Ngeresnya sama punya apa?
grup gua maksimal segini gede sasisnya. Ya, yang dimuat di situ cuma motor. Sama box.
High X tuh ya. Jaga-jaga kalau yang buat apa pasti.
Kalau yang ini kita tinggal ganti sasis. Enggak. Berapa sih? Sih juga udah masalah. Bang, aslinya berapa sih kita kemarin beli? 30 kalau nggak salah selembar kan A3. Potong sendiri juga guys. Murah. Paling merek dikit pas motor. Paling kemarin.
Is it showing up? No.
Kita tanya juga. Ya sama di sini.
You're using a personal account.
Yes. Oh, tapi request access. Hah? Apa robot? Tulisannya sih 57 mili kalau di deskripsi produk. Diameter mananya nih? Diameter total 57. Lubangnya harusnya 8. Kita malah di
Try again.
Gue pas ke akriliknya 5 cm.
Oke.
Bisa.
Sudah.
Plain bearings are used for rotational, sliding, reciprocating, or oscillating.
Okay, are you guys done? Okay. Okay. Today we're going to continue our discussion on bearings. Let's review again. Shafts are always supported by bearings, right? It always rotates, so it's not going to rot against a fixed surface, otherwise you'll be worn out by no time. So every shaft that rotates, and especially ones that receives load, two kinds of load, what are they? On a shaft? Axial and radial load. So, say you have a motor, okay, that rotates. So the arrangement, this is the shaft with the loads. Let's say pump, right, or mixer, or blower, or grinder, anything, right? You have a load here, many different loads incoming. This shaft has to be supported on bearings at 2 points. This guy also have bearings here, right? And in the back. It can be a rolling contact bearing or plain bearing. These two shafts has to be connected with a, what we call the connector here? It's a coupler, okay? A shaft coupler. What is the function of a coupler? Obviously, you want to transmit torque, but why need a coupler? I mean, why not just weld it together? Or fix them somehow? Allows misalignment because the mounting of this and the mounting of this motor might not be perfect, or most likely it's not. Nothing is perfectly aligned. So there will always be some misalignments. Two kinds of misalignments. The two directions are, what is that parallel misalignment called? Like this. Forgot? This is called an offset misalignment, and there is the angular misalignment. Two directions, two different kinds of misalignments. So again, I mean, this is exaggerated, but you always have a coupler, okay? So this coupling allows some offset misalignment and some angular misalignment. Now, going back to the bearings, so these are mounted on bearings. We discussed rolling contact bearings. The construction of a rolling contact bearing has, what are the elements of a rolling contact bearing? Outer, inner, and the rotating elements, right? The rolling elements. The elements can be in two shapes. Rollers and balls, okay? Now, let's shift to a plain bearing. Okay, a plain bearing does not have any roller or balls going around. It's also called a bushing. So you got plain bearing is kind of a generic term. There are different kinds. One spatial type is called a journal bearing. Well, let's start with metal, usually soft materials. Okay, it's just bronze, brass, and then there are polymer, i.e. plastics. Okay, so you can have nylon, PTFE, which is Teflon, just like the coating on your pots and pans and others. Okay, and then there is hydrodynamic bearing. Hydrodynamic bearing, also called a journal bearing, is the one that floats on oil. Okay? So you got oil, so you got this outer race, you got the shaft, and then you got the oil supporting the shaft, literally floating. And this oil is usually under pressure, not always. You can also use grease for a hydrodynamic, but in many applications, it's actually oil flowing. Okay? So that's a hydrodynamic. So we'll talk about that. So these are the three main categories. The discussion on these two, the calculations on plain bearings, like metal or polymer, is the same. This is kind of a spatial calculation. We will not get into it because it's pretty involved. It involves some fluid mechanics because pressure actually builds up underneath and it's actually supporting it. We'll only do calculation on these two. These two are also called boundary or film lubricated bearings. So there is some lubrication, but it's usually just a film. While here, it's actually pressure. Okay? So here, you often have oil pressure or some pressure build up. But here, it's only a film. So it's boundary lubricated is the technical term for it. Okay, so let's look at some short videos before we get into calculations.
Oscillatory motion. The bearing remains fixed while the journal slides on the bearing's inner surface. The bearing is basically a sleeve mounted on the shaft and fit into the bore. Plain bearings are inexpensive, compact, and lightweight. They have high load carrying capacity. It is used extensively in applications in the agriculture.
Visit our website for all kind of your bearing.
Okay, so that's a short one.
Plain bearings, which are also known as bushes, bushings, or sleeve bearings, are usually cylindrical in shape and contain no moving parts. Standard configurations include cylindrical bearings to support radial loads, flanged bearings to support radial and light axial loads, thrust washers, and flanged thrust washers to support heavy axial loads, and sliding plates of various shapes.
Now, this sliding plate, I mean, it's not a shaft, but it's also a low friction surface for sliding. Okay, in this case, we're just talking about the cylindrical ones.
Manufactured in internationally recognized standard dimensions for ready stock availability, they can also be produced in special sizes or shapes and incorporate special features such as lubricating grooves and holes, notches, tabs, according to the application requirements. Plain bearings are highly versatile as they can operate under dry, greased, and liquid lubricated conditions, are suitable for all types of movements such as sliding, rotating, oscillating, or reciprocating motion, and can support different load and varying temperature configurations. Their thin-walled construction allows compact designs and weight reduction. The principal benefits offered by plain bearings are low friction for improved equipment operational efficiency, along with high wear resistance for greater reliability and service life. Additional plain bearing benefits include quieter operation because of the lack of internal moving parts, greater resistance to damage from oscillatory movements, and higher load capacity and resistance to shock and edge loading. The composition and structure of each bearing product has been designed to offer these benefits according to the specific working conditions of each application. For example, to avoid air conditioning failure, air compressors require high-precision, low-friction plain bearings that can operate without seizure under boundary, mixed, and hydrodynamic lubricated conditions due to frequent stop-start. Plain bearings in steel production equipment work with high shock loads in a hot and aggressive environment. This calls for plain bearings with high load-bearing capacity and dry, solid lubricants that are capable of withstanding the high temperatures. Product selection depends on the operating conditions of the application and the performance requirements. They're
Okay.
and flanged.
So, they are shaped differently, and it's usually for the purpose of assembly. For example, you got these flange bearings. Anybody can tell me why there is that flange? I mean, you don't have to, but it's practical. So usually you have some block that you mount it to, right? So you have a block, you want to mount a shaft, and you drill a hole, and you want to put a bearing on it. So you drill a hole, and then you want to put these things on it, and then the shaft goes in, right? The flange helps you kind of sit on top of it. So let me draw with a different color. So if that is your block, and you already drill a hole on it, and then you want to mount your bearing or the bushing, right? So it's going to sit like that, okay? The round, right? But pressing it on, sometimes it's helpful to have a flange like that. Am I drawing too small? Can you see it in the back? Okay, so there is this lip. You just press it on, hammer it on, it's there, right? So these flanges are just practical to have. It also often has a split, so it has room to go into a smaller, and it kind of locks itself in. So the split, so it's a split, so you can just push it in, mate itself, and then there is some preload, it sits itself in. Can you imagine that? Yeah. If you see something like this with the holes, guess what the holes are for? Some lubricants, okay? Usually solid ones. Sometimes they fill this with graphite. Graphite like you find in your pencils. It's actually pretty low friction. If you try to touch the graphite on your pencil, it's actually pretty slippery, right? Even though there is no oil. So it's called solid lubricants. So solid lubricants you can coat it with that. And the nice thing about solid lubricant is it's not messy. It doesn't collect dust and then become a goo, like a glue, like gunk. Yeah, I mean it's just collect contaminants, right? These solid lubricants does not collect contaminants. That's what's nice about it. And it also is there without any additional oil you need to put, right? You cannot push it out. So because it's integrated inside this bronze bushing, as it wears out, it's still there, and it keeps self-lubricating, right? So self-lubricating bushing is where you actually impregnate the lubricants into the bushing. So you don't have to keep lubricating. That's nice. So now, why would you use, where is it? Why would you use plain bearings rather than bushings? Well, first of all, it's cheap. Cheap is always good. But it's low enough friction. It's not as low as rolling contact bushings. Coefficient of frictions, we're talking about 0.05, 0.1 at most, but usually under 0.1, not 0.001 though, right? So it's not as good as ball bearings, but pretty good enough. High wear resistance, quiet operation, no, or I mean any ball bearing that is damaged will give you a lot of noise. Very quiet. It's just practical, right? It's good with shock loadings. This is why you don't see ball bearings in your engines. Because think about the combustion. You know, the piston going up and down, it's under a lot of shock loading. It's going to damage the ball surface. It's going to indent the inner race and the outer race in no time. I know small motorcycles use ball bearings. Not many. I mean, most of it. Yeah.
It's low maintenance.
Yeah. Yeah. It's low maintenance. Yeah. It's not something you have to maintain for the solid lubricants, especially.
Bushings and bearings are almost certainly terms you've heard of.
All right. Let's watch with this one.
Welcome to my YouTube channel. Spherical plane bearings are types of bearings that have an inner ring with a convex outside surface and an outer ring with a concave inside surface. The two rings are mounted together, so there are no rolling elements in between. Uses and applications. Spherical plane bearings are suitable for applications where alignment of movements between the shaft and housing have to be accommodated. When they can withstand heavy loads and shocks, they are also referred to as heavy-duty spherical plane bearings. Rod end bearings. Rod end bearings, also referred to as rose joints, consist of a knife-shaped head with an integral shank, which is used as housing for a spherical plane bearing. The internal thread is usually left or ring hand female, while the external thread is male.
So these are spatial shapes also. It's not just a straight cylinder. It has like a ball joint. Okay, so it can rotate a bit, and it's just something that is useful for some applications.
Uses and applications. Rod end bearings are very easy to mount, provide a compact and lightweight design, and are a good alternative to a conventional housing element. Rod end bearings are often used in control rods, mechanisms, and linkages, being easy to integrate into various applications.
You can see it's also self-aligning, right? So linkages does not have to be exactly 90 degrees.
Bushings. The most common type of plane bearing is the bushing or bush, which is an independent element inserted into a housing to provide a supporting surface. The shape is usually cylindrical, the standard configurations being the sleeve bearing and the flange bearing. A particular type of bushing is self-lubricating bushing. Uses and applications. Bushings are akin to thin tubes most commonly used for machinery with rotating or sliding shafts to improve efficiency and reduce vibration and noise. Bushings can be used for drilling operations and drill jigs, hydraulic external gear pumps and motors. Two-piece plane bearings, also referred to as full bearings. Two-piece plane bearings are used in industrial machinery where larger diameters are required, such as crankshaft bearings.
So these are hydrodynamic bearings. These channels are meant for the oil flow. We'll talk more separately on that.
They are made of two parts called shells, which are kept in place using different mechanisms. Uses and applications. These types of bearing units are composed of a lower part positioned on.
All right. That's good enough for that. Now, there are a lot of polymer bushing are very popular. I usually invite this company called Egus. They make a lot of plane bearings, and their specialty is the polymer bushings, so the plastic ones. It's proprietary material, and I usually have the samples up in the 20th floor. But there's some big advantages over bronze bushings.
Always great. never self-lubricating, never maintenance-free,
Come on.
never self-lubricating, never maintenance-free, never predictable. Always self-lubricating, always maintenance-free, always predictable.
I lied.
Hi, my name is Nicole Lang, and I'm the iGlide product manager here at iGUS Incorporated. In this video, we're going to do an overview of iGlide bearings, what iGlide is, and what we can offer. Let's start by talking about what iGlide is. iGlide materials are developed and engineered in our German facility. We develop a variety of different materials for use in different applications. iGlide materials are all self-lubricating and maintenance-free. That's made possible by their structure. All iGlide materials start out with a base plastic for wear resistance. We add fibers and/or filaments for strength, and then we finish it off with dry lubricants to mitigate the friction in the system.
Okay, so these solid lubricants are actually injection molded together with the plastics, with the main matrix material. As a result, as you wear it out, like say this is the thickness, okay, and you start mix, right? I mean, you wear out the surfaces, but the material always contains lubricants in it, and so it's already built in, and it's dry, so it's not going to collect dust.
And allow for a nice bearing surface. We have over 55 different standard materials ready for use in a wide variety of applications. If you need low moisture absorption, FDA compliance, for use on different types of shafting, whatever your needs are, one of these 55 materials are sure to meet them.
Especially food and in the food industry and drug industry, you have to have certain material that is approved for food. Anybody want to say why? Why is it especially important? What will contaminate it? You're gonna wear this out, right?
Yeah.
Where do those materials go? Like everywhere, right? So as you have sliding surfaces, all this dust will go anywhere into the air and it'll go to your food. So it has to be food grade. Any machineries in your automation.
For our standard offering, our standard shapes include sleeve, flange, and thrust washers. In sizes from 1.5 millimeter up to 195 millimeter inner diameter for metric, and then we have from 1/8 of an inch up to 5 inches inner diameter for inch bearings or imperial bearings. We also have piston rings, very easy assembly, able to snap right into the housing or right onto the shaft. In addition to that, we've developed a variety of different designs for use in different types of applications that are still considered standard items available to you off the shelf. These include our pre-tension bearings. All of our pre-tension bearings are meant to eliminate the amount of play between the bearing and the shaft, so virtually eliminating any amount of clearance. They're barrel-shaped. When they're pressed into a housing, it compresses down on the shaft, and those fingers eliminate the clearance between them.
Do you see the little cutouts? So if you look at the bearing, like a standard plain bearing will be like this, right? So straight cut. Say this is made for a shaft of what? 10 millimeters, okay? Now, what that pre-tension does is basically it has a finger like that on both sides. So what happens to your shaft? It is actually a little bit clamped, right? So this is your shaft diameter. Okay? So this finger will deflect, obviously, because it has some cutouts. So it will deflect, but it will, so after assembly, it'll be like this, right? It's not going to be so, right? So it's going to kind of hold the shaft and eliminate any play. That's what's nice about it. Because this stand and the shaft, I mean, there will always be some clearance. And you want that clearance to be taken up so it's not shaking.
In the flange option, there's some axial compensation, which allows for the reduction or elimination of clearance in that direction as well. In addition to our standard pre-tension bearings, we also offer nitride rollers. These were developed for the packaging industry for end-of-line conveyors. These have extremely tight deflection radius and are very suitable for these types of applications. We also offer 2-bolt flanges using the same wear-resistant iGlide polymer blends as our other materials. In addition, we have double flange clip bearings, which are meant for sheet metal applications. They snap in really nicely and are really effective. Used quite a bit in the automotive industry.
So this is for sheet metal applications. Especially sheet metal is very sharp, right? So sometimes you want to snap in these bushings just for cables to go through and the cable will not be cut. So this is to cover the sheet metal.
Along with our 2-flange system for clip bearings, we also have a single flange, which has a split, very flexible, perfect for easy assembly. And newest to our standard line of iGlide products and designs, we also have rollers available as well as gears. So we're really looking forward to expanding our offering with these
Self-lubricating too, so no need for oil.
2 products. And although we have a wide variety of standard options available, we do recognize that certain applications require custom parts. And for those reasons, we've developed our semi-finished product line, which includes bar stock and plate stock. Bar stock is available to be machined out of 35 different iGlide materials. These
So you can buy and just machine your own.
range in diameter from 10 to 100 millimeter for flexibility, and our plate stock from 2 millimeter thickness all the way up to 50 in a wide variety of plate sizes. And speaking of customs, along with our option for prototyping, we have a whole host of custom parts that we've developed with customers. These are done using our injection molding process or a variety of different manufacturing methods that we have. They're suitable for use in a wide variety of applications. So whether you're looking for something that's quiet, lightweight, or wear resistant, we have a product for you. These are typically used in any application including ag and construction, packaging, automotive, medical applications, as well as bicycles, material handling robotics, and really the list goes on and on. If you have any questions or would like to discuss your application further, please contact me at the email below. And to learn more about iGlide, click on the link below for more information.
All right. So many different material. I mean, they have their own proprietary material, obviously, but they also implement it in linear motion. We'll talk about linear motion later in this course also, but very practical for linear motion application. So any gliding surface, very quiet compared to a recirculating ball bearing type. No corrosion too, that's right. Yeah, they do quite rigorous testing. Alright, so I usually invite one of the engineers over from EGUS. They have their office is right down in BSD. So, anyways, great products, not that cheap, but great products. I mean, it's German. What do you expect? Okay, so that's a good overview of plain bearings, just the many applications of it. Now we're gonna do some calculation of the plain bearings, and All right. Yes. Yes, from the material. Many of the bronze bushings can also be self-lubricating. They use what is called a powder metallurgy. So a powder metallurgy process, I think I forgot to mention that. The powder metallurgy is basically powder press. Anybody knows powder pressing?
Metal powders used for parts production can be a combination of various elemental particles or pre-alloy powder. If elemental powder is used, each of the ingredients that will comprise the desired part are mixed in proper proportion into a uniform blend.
So you mix in whatever, if you want to mix of like nickel, chrome, whatever, you mixed it in, and then you press it.
With pre-alloy powder, the proper proportion of ingredients is already present in each particle. In either case, additives such as binders and lubricants are usually added. The powder is then consolidated in molds or dies, shaping and densifying it into a compact of the desired part. At this point, the part, or compact, is in a green state, where the powder particles are just lightly joined together. In this state,
So these are still packed powders. These are not solid yet, but they are high pressure presses.
the parts have a so-called green strength, which is usually only sufficient for handling purposes. The parts are then transferred to a sintering furnace. During sintering, parts are heated at a temperature below the melting point or range of the base metal, but high enough to metallurgically bond the individual particles. Sintering further densifies the parts, increasing strength. Final part density is extremely important. Although controlled porosity is required and achievable for certain parts, the performance of structural parts increases directly with increasing density. The common methods of consolidating and shaping metal powder for parts production include mechanical pressing, injection molding, and isostatic pressing. Most parts are made by mechanical pressing and sintering. Parts are usually small to moderate in size and can be simple or complex in shape. They
So you can
can be
powder press a gear.
very thin or thick, and can also have one or more levels, shallow or deep holes, and various other details. Parts produced by mechanical pressing can be net or near net in shape and have very close tolerances. Part production rates are high, from several hundred to thousands of parts per hour.
When it says net processes are desirable because they do not waste material. Say, to create this plastic cap, let's say this plastic cap weighs 2 grams. How much plastic material do I have to spend for each one of these? Not 2, right? 2.5, 3. Why? This injection molding. You guys took manufacturing processes, right? What will exist? What do you also have to injection mold other than the part itself? What do you call that piece? The runners. Okay, so you'll have runners, you'll have gates, you'll have all kind of other features. So it's not exactly net process. There is some waste material you have to spend. Yes, you can grind them, you can remix them, but it's not going to be as good. Anything that is reground and used. So these powders, though, I mean, think about it. Anything that is not becoming the shape of the part can be reused. Like you're using like net. Like if you need 2 grams, then you use 2 grams of powder, and everything just mixed in again and keep becoming parts. So it's a nice net process.
In mechanical pressing, the powder is automatically gravity fed into the die of a mechanical or hydraulic press and consolidated to a specific density. Pressures of 10 to 60 tons per square inch are created by the vertical action of an upper punch or by the double action of an upper and lower punch. Pressing is typically at room temperature, although elevated temperatures can also be used. Core rods are used inside the die to control formation of holes parallel to the direction of pressing. If the part being made is thin and uniform in height, the powder can be pressed from one side by the upper punch. When that punch withdraws, a lower punch raises the part out of the die. The part is then ejected by the wiping action of the powder feed chute, which also wipes powder for the next piece into the die.
Okay, this is not a class on manufacturing process, so we can skip this. Okay, but the point is that many bushings are made using this process. Okay, cover that. So let's talk about bushing calculations. So if you talk about plain bearing calculation, we're talking about pressure, okay? Because if you think about the shaft on a plain bearing, you know, there is a radial load, there is the axial load, and this is basically a surface with pressure. And so if this is the shaft, or the bushing is outside of it, and you have a radial load, this radial load is actually resisted by a distributed force, right? And so the failure of bearings or bushings will be governed by pressure and velocity, because a high enough velocity will also cause heat combined with pressure. Okay? So you have pressure and rubbing at the same time. Okay? So think about it like you're doing that to the bearing surface, even though it's round. But if you open it up, you know, a cylindrical surface, you open it up, what do you have? What kind of shape? Rectangle, right? So think like this rectangle table is actually a bushing opened up. And then there is, you know, there are objects flying through it with pressure. And that's what's happening. And so you are actually converting this friction into heat. There are several things that you're going to check, and we're going to just jump into the exercise on this. Pressure will limit the function of that bushing. So when you're about to select a bushing or a plain bearing, you're governed by this Pmax, Vmax, maximum linear velocity, and then a combination of that. Now, PV, if you combine pressure or multiply pressure with velocity, what do you get? What is force times velocity? Going back to physics, it's watts, right? Power. So it's kind of a rate of heat generation. So you can think of PV, because P is part of F, right? Divided by area. But the pressure times velocity gives you an idea of how much heat you're generating actually, how much power is the capacity of this bushing. And finally, there is wear, and there is also temperature. Not here, next is temperature. You also have temperatures, okay? So we'll address all that. Finally, this is kind of a recommended design constraints on length to diameter ratio. So if you look at a bushing with very long versus the diameter it'll be awkward. So there's usually a nominal ratio L divided by D. Okay? So with that, let's do some exercises. This oilless SP500 alloy breast bushing is just a type, basically. We're going to select, or we're going to assess whether this is allowable or not. Okay, is it still within the prevent myself from walking back and forth here. Okay, so here is the bushing we're about to evaluate. It's a breast bushing. The length and the diameter is given. This is how it looks like. Okay, so this is the length. This is the inner diameter, 25. So length is 0.025 meters, and I'm just converting everything into meters because we're going to do everything in meters, SI units. The diameter is 0.025 meters. The radial load, 2250. Let's read it again. So 25 millimeter long, 25 millimeter diameter, operates in a clean environment at 21 degrees C. We'll take that in later. Okay, clean environment, 21 degrees C. The allowable wear without loss of function is 0.125 millimeters. So it's 10 to the negative 3 meters. I'm just converting it here instead of in the formula. Okay? The radial load given, the shaft speed, gonna call it N, 200 RPM. Estimate the number of revolutions for radial wear to achieve this, right? So when, in other words, right, when will it reach limit? The wear limit, meaning you need to replace this. What is the lifetime of this bushing? So first, you evaluate the pressure and velocity limits.